Hi, we are from Team Neuron. Our theme is infrastructure and the project is accident detection.
I'm Sherwin Joseph. I'm a fourth year BTech computer science student from Christ University, Faculty of Engineering, Bangalore.
I'm Sreyan Ghosh. I'm a fourth year BTech in computer science student from Christ University, Faculty of Engineering, Bangalore.
I'm Rohan Roney. I'm a fourth year BTech computer science student from Christ University, Faculty of Engineering, Bangalore.
Hi, I'm Sukumar Dadiredy. I'm a fourth year BTech mechanical student from Christ University of Faculty of Engineering from Bangalore.
Hi, I'm Rohan Roney and I'll be discussing the problem statement. As we all know, accidents are a major problem in our day to day lives. Surveys conducted by the World Health Organization reveal that almost 1.3 million deaths happen each year from road accidents. And these numbers only increase multifold when we are talking in reference to the developing nations. India alone holds a dubious average of close to 17 deaths an hour, which amounts to close to 150,000 deaths a year. And the sad fact is that most of these deaths could have been avoided rather easily. An accident usually has three phases. The first phase is the one wherein the death occurs within the first 5 minutes, and these account to the 10% of the victims. These are situations which are rather unfortunate, and there is nothing that we can do about it. The second phase is the one which occurs days or weeks after the accident, and this phase has a death rate of about 15%, and it takes medical care and resources to avoid. The third and the most important phase is the time of 1 hour after the accident, which has the highest mortality rate of close to 75%. The objective of our project aims at aiding these victims.
Hello, my name is Sherwin Joseph and I'll be discussing about the current state of the problem. We came across two types of accident detection solutions. The first one was an app-based accident detection solution and the second one was a sensor-based one. The first one, the app-based accident detection system, it was an application that was installed on a smartphone. This application used the sensor data from the accelerometer and the gyroscope to help detect an accident. And once it detected an accident, a contact person, which was preset on the application, was informed about the accident. This is a good method, but it has its major flaws. The first one being that it's highly unreliable due to its dependency on sensors, which can either malfunction or give incorrect data because an accelerometer and a gyroscope is not meant to detect accidents. The second one was it can lead to a lot of false positives. We came across two examples which portrayed an accident detection through an application. The first one was an auto accident app, and the second one was an SOS Smart app. We'll be showing these examples next.
Introducing the Auto Accident app, engineered for safety and designed for peace of mind. What makes the app so great is, if you're involved in an auto accident, it can detect that.
Auto accident detected.
Notify family members instantly of the accident location.
Your family has been notified of the accident. Help is on the way.
It can do that.
That was the auto accident app. Next is the SOS Smart app.
An app that uses the internal sensors on the user's smartphone to detect a traffic accident automatically. Once the accident has been detected, SOS Smart sends a notification to predefined contacts with the exact location of the accident, allowing the contact to quickly call emergency services. Download SOS Smart.
Next is the sensor-based accident detection system. In a sensor-based accident detection system, impact sensors are positioned in a car to detect an accident. Once the sensor detects a crash or an impact, an alert is sent. The drawbacks of these sensor-based accident detection systems are that sensors are to be placed in every individual car, which renders this concept to be very expensive. Also, not all cars come equipped with such sensors. In case of India, Not all people can afford such expensive cars, which come with equipped impact detection sensors, which makes this system a luxury only a few can afford. We came across two examples for sensor based accident detection systems. The first one is by Lexus. Lexus developed something called Lexus Inform, which has a collision notification feature based on airbag deployment and sensor data. So once the Lexus collision detection system detects a collision, it notifies the local authorities and the local emergency services about the accident via an agent which Lexus has placed. The second one is something similar, which is called OnStar. What it does is that based on the sensors in the car, once those sensors detect a collision or an accident, it informs the local authorities nearby. Overview of the solution. Accidents have been a major cause of death in India. More than 80% of accident related deaths occur not due to the accident itself, but due to the lack of timely help reaching the accident victims. In highways, where the traffic is really light and fast paced, an accident victim could be left unattended for a long time. The project is titled Accident Detection System, and the intent is to create a system which would be able to detect an accident based on the live feed of video from a CCTV camera installed on a highway. The solution is to not only make the system smart but also intelligent. The idea is to take each frame of a video and run it through a deep learning convolutional neural network CNN model, which will be trained to classify frames of a video into accident or non accident. The main objective is to incorporate a system which is able to detect an accident from video footage provided to it using a camera. The system is designed as a tool to help out accident victims in need by timely detecting an accident and henceforth informing the authorities of the same. In this system, we have a Raspberry Pi 3 B Plus model, which acts as a portable and remote computer to be set up on a CCTV camera. For demonstration purposes, we used a Pi camera which can be directly set up on a Raspberry Pi. We pre-trained a CNN LSTM based image classifier to be able to detect accidents by training it on two different sets of images and sequence of video frames. The two different sets of images were accident and non-accident. When a video is shown to the Raspberry Pi through the Pi camera, it will run each frame of the video through the deep learning model proposed and then predict whether the given frame is an accident frame or not. If the prediction exceeds a threshold value preset to the Raspberry Pi, it then initiates the GSM modules set up with it to send a message to the nearest hospitals and police stations, informing them about the accident which has been detected with the timestamp of when it occurred, the location of where it occurred, and the frame at which the accident was detected for further analysis. Also, an emergency light lights up in the control center regarding the accident. The system has been made smart because the proposed system provides a very viable and effective solution to the problem. The proposed accident detection system can track an accident at its moment of occurrence and send an instantaneous alert SMS regarding the accident to the nearby hospitals and police stations, which includes details like timestamp and geographic location. Unlike other systems in use, which consist of expensive sensors and unwanted hardware, the proposed system is much more cost effective and foolproof, with a much improved accuracy rate than its counterparts, mainly due to the deep learning model that is being used. An accident detection system would help in providing timely help for accident victims who could be left stranded on the roadside with no help reaching them. Timely help reaching the accident victims is of utmost importance, as life and death could be a matter of few minutes. Hence, we created a system which is smart enough to detect accidents in real time and alert the concerned authorities about the same.
Hi, I'm Sreyan and I'll be discussing about the model. For prediction of accidents, we developed a hybrid model which is a blend of two types of deep learning models, CNNs or convolutional neural networks and LSTMs or long short-term memory networks. CNNs are generally used for image classification and feature extraction from images. LSTMs are generally used with sequential data. LSTMs are a type of recurrent neural networks and helps learn long-term dependencies in the data. Since in our problem we are not dealing with still images but videos which are actually a sequence of images, this is the main reason we developed this hybrid model. This model extracts features from images with the help of CNNs, and we replace the last bottleneck layers with a couple of layers of LSTMs with 5 time steps. This means that the LSTM takes in the current frame and 4 frames prior to this frame for prediction. Since our video runs on 5 FPS on the Raspberry Pi, this means that we get one prediction every second. For the CNN part of the model, we used the award-winning architecture invented by Google, which is Inception v3. For training, we used transfer learning, whereby we freezed the weights of every layer in the network except the LSTM layers and the dense bottleneck layers. For the LSTM part of the model, we have two LSTM layers, each with 256 hidden LSTM units, and followed by two dense layers which are 64 and 32 units long respectively. These are all finally followed by a dense layer with a single hidden unit with sigmoid activation for our final classification. For training, we used a dataset which consisted of 5000 total images, which was divided into 2500 accidents and 2500 non-accident images. Additionally, we have a set of 1000 images, 500 each of accidents and non-accidents used for testing our model. All these images were downloaded from Google using a batch downloader. For building our model, we use deep learning frameworks like Keras and TensorFlow. Additionally, we used OpenCV to pre-process the image used for training the model. Keras, which uses TensorFlow at the backend, was used in the initial stages of testing. Later on, we moved to TensorFlow to make our deployable model and used TensorBoard for monitoring the training of our model. OpenCV, which was mainly used for pre-processing, was used to resize the image, to scale the pixel values of the image, to facilitate the training, and also to denoise the image before training.
A brief description of the various physical entities used in our project is as follows. Raspberry Pi 3 Model B+. There were 4 very specific properties that we wanted out of a computational mechanism, namely reduced size, portability, low cost, and a decent computational power, all of which were satisfied by the Raspberry Pi Foundation's latest model of the Pi, the Raspberry Pi 3 Model B+. The Raspberry Pi 3 also supports Python programming language, which helped us to easily integrate the model with the actual working solution. Despite its small size, the Pi is packed with various features like a 1.4 GHz processor, a 1 GB RAM, and most importantly, 40 general purpose input-output pins, which help us to easily interface the hardware with the Pi. Pi camera. Since we were creating a prototype of the solution and there were monetary limitations, we used a Raspberry Pi camera, which is actually a 5 megapixel camera, to mimic the functionality of a real CCTV camera. To our surprise, despite all its limitations in quality, it actually gave us decent results. It was capable of supporting both still images up to 1080p as well as videos. And since the images that were obtained were in JPG format, they were easily fed to the model for further analysis. GSM module SIM 800L. The global system for mobile communication is one of the most used telephony systems. The module that we have used for our project is SIM 800L, which helps us to connect onto any of the global GSM networks using just a 2G SIM. The SIM 800 module can be utilized for GPRS as well as remote SMS transmission. Thus, we can easily send and receive messages using cellular network along with an arbitrary location based on the tower to which the SIM is synced at that particular moment in time. The module itself is compact in size and has a low current consumption. The communication is achieved using AT commands.
Working demonstration of our model. In this demonstration, we will be running a CNN LSTM based accident detection model on a few accident cases to show how it predicts accidents. We have done this prediction on crash tests conducted by companies on vehicles, since getting videos of an actual accident taking place is really tough. We do have an example of a real-life accident which will be shown in the end. Due to the time restrictions we had to come up with the model, our present system is not a perfect system. But keeping that in mind, our model is still able to predict accidents to a considerably high accuracy rate. The model will be improved for deployment. We will be able to see the predictions given by the model for each frame of the video. The first example is a Volvo crash test conducted by Euro NCAP. Source of all our videos is YouTube.
So now we'll be showing you the deployment of the entire system. So the main entity of the system is the Raspberry Pi. This is the actual processor on which the entire system works, and the model that was actually trained on GPUs is actually run on this system. The second entity is the GSM module, which is the second most important entity of the entire system, as it is used in order to send the messages to the nearby police stations and hospitals. So once the accident is detected, the message is actually sent to the police stations, but for demonstration purposes, the message will be actually sent to this phone. The third entity is the Pi camera. So this camera is actually going to mimic how an actual CCTV camera works. And this is an emergency light which will be deployed once the actual accident has occurred. So that is the physical entities that are present in the system.
So now we'll be demonstrating the actual working of our project. We will be mimicking an actual accident through the screen of another laptop and capturing the same through a Raspberry Pi camera. As we can see, this is how it looks on the Raspberry Pi. As we can see, when the accident reaches 99% or when the actual accident happens, there's a message that comes and the LED bulb glows. As we all know, a deep learning model goes through a lot of computations before actually providing the final predictions. The Raspberry Pi processor is not fit for running a deep learning model. However, we optimized OpenCV and our DL model so that the computations run much faster. Our final plan is to serve the model as a REST API in a cloud server in Google Cloud using Flask to speed up the working of the whole system.
Since we are still in the prototyping stage of the system, we are not completely sure as how to capture the end user experience just yet. However, one thing we plan to execute once we are sure of working of the system, we aim to approach a police station, namely Kengeri police station, and show them the system and gather the necessary feedback, including details as to how we practically can collaborate, test this on the roads. We also aim to contact a couple of hospitals as well, in order to practically see the time frame between accident detection, message reception and response in order to conclude on the effectiveness and feasibility of the system. The proposed system is a product which would have influence on the life of people without day-to-day traveler having to know about its existence. Since it uses a CCTV camera to predict accidents, which acts as a mode of surveillance on highways, it means that no additional infrastructure needed to deploy the model in real life. All the system does is to make the present infrastructure smarter and more intelligent towards detecting accidents. Since the system uses Raspberry Pi and a minimum hardware components, its cost deployment is lesser than 5000 INR for the complete system. The system once set up would need a minimum requirement of maintenance and gives an accuracy rate of 90% higher and more efficient because of more efficient CNN algorithm present today.